All right, so I want you to think about something with me for just a minute. If I had something like tell me what you would know.
You get the X factors, they have a common denominator.
They do have a common denominator. If I want to solve it for x. Okay, so cross multiply is always an option when you have two. Okay, so kind of, yeah, this is, yeah. Look at what y'all said it in the beginning. You were right on it. It has a what? It's already got a common denominator, right? We all agree? So would you agree if the bottoms are the same and all I have is one fraction on either side, if the bottoms are the same, then the tops must also be the same?
Yes.
You agree with that?
Yes.
Could you then solve it for x? So the point I'm getting to here is if the denominators are all the same, then you could use the numerators to solve. Does that make sense? Because if the denominators are the same, then the numerators must also be the same. So you would use those to set up and solve from there. So I'll show you what I'm talking about. I'll give you just a second. Hit record. All right, so let's look. What if they're not the same? Now, somebody said cross multiply, and cross multiply is always an option when you only have two fractions, okay? You only have two fractions, cross multiply is definitely an option. But y'all know me, I like a method that works all the time, not in some scenarios. I'd rather just know how to do it anytime than, oh, is it this or is it this? Then I need to do that, then I need to do. So I like the LCD method for solving any type of rational equation, okay? Any type. So because these don't have common denominators, could I force common denominators?
Yeah.
Yes, and essentially what you're doing is cross multiplying, but this works all the time if you think about it this way. To solve, force LCDs an entire equation. So we'll get to some that are a little more involved than this one. Okay, but for the sake of example, for the first one, let's look at it. What's the LCD of these two fractions? That's right. Nothing needs to be factored, right? Right. So, yep. Every single fraction in your equation needs to have the same LCD. So force them. So the first one needs what? A 4x plus 5. The second one, nothing too hard yet? Yes. We'll get to them. So now comes the fun part. Drop the denominators because they're the same and solve. So once you force the LCDs, drop them. So now I have 3 times 4x plus 5. This is everybody's favorite section always when we get here. 9, yes, but I'm going to take it a step at a time. Okay. Now you can solve. This is an easy solve. So Joseph already told us it's 12x plus 15. And it's 9x plus 9. Now, if you can't solve this at this point, we've got bigger issues. What do you move first? I would agree. I always move the smaller x 3x, I'm going to move the 15 at the same time. Does that confuse anybody? 9 minus 15 is negative 6. So what is x? Now, essentially on this one, what we did was we did cross multiply. 3 times 4x, and then 9 times that. Yeah, distributing. Yep. Okay. I'm going to give you a second to try this one on your own. Now, again, your directions are going to ask you to check for extraneous solutions. If you plug it in and the equation does not work, then it's extraneous. If it works when you solve it, if you solve it and you get an answer, and then that answer, you know how you learn in Algebra 1 whenever you check your work, you plug it back in? Yeah. Sometimes when you start dealing with squares, if you plug back in, it doesn't work. So if you plug it back in, it doesn't work, it's extraneous. It just means it worked when you solved it, but it doesn't work when you plug it in. So it looks like a solution, but it's really not a solution. All right, I'm going to pause. Here we go. The LCD, most of you have figured out at this point, is x minus 3x plus 3. Okay. This one needed an x plus 3. This one needed an x minus 3. Now, here's where some of us started to differ. If you went ahead and simplified the right side, like adding and subtracting rationals, which is not wrong, you eliminated the extraneous solution, which is A-okay. That's fine, okay? If you did the LCD method and you just went ahead and dropped off these denominators at this point, you would have 6x plus 18 equals 8x squared minus 4x squared plus 12x. So I've got plus a minus 4x that distributed through there, that's why.
Do you not solve the right
That's what I did.
You do not have to. You can. That's what I said. If you did, you eliminated whenever those x minus 3's canceled out, you eliminated one of the extraneous solutions, which is fine.
But they're not going to ask for right?
All right, so I'm going to make it equal 0 because I do have a quadratic. So I got 4x squared. If I subtract 6x, I get plus 6x, and if I subtract 18, I get minus 18. Of course, I can take a 2 out of all these.
3x.
Ah!
2x.
All right, so now I need to factor that. Come on, pen. What is it? 6 and negative 3, that's right. 2x squared minus 3x plus 6x minus 9, which would give me 2x plus 3. Right, nope. 2x minus 3. Sorry. I'm trying to skip steps. 2x minus 3 and x plus 3. If I set equal to 0, I get 3 halves and think about it like this. If I did this,
No, I know that is not what I'm asking.
if you simplified the right side first, you did not get negative 3 as a solution. That's okay. You eliminated the extraneous early on. Negative 3 is an extraneous if you plug it back in. It's okay. Mm-hmm.
No.
Would it be okay if we only got the one?
Yeah.
What if we got an extraneous and not the solution?
That's an issue at that point then, yeah.
How could we only not
Some people went through on this side and they looked at that as a subtraction problem and they simplified that side completely first before looking at the other side, which is fine also. Let me show you one more. This is special. Y'all always say they pop up on homework and we haven't talked about them, so I want to make sure I show you one more.
I have a question.
This one has two true solutions.
It's not extraneous.
Yeah. I'm listening.
What's your
Okay. Last example. It's one in every class. All right. Stop, Joseph. There's a Band-Aid in my top right drawer. That's nasty.
I'm doing like Indian I'm doing Indian art.
Joseph. All right. The trick here with the 1, because it's 1 over 1, so when you find your LCD, it needs everything. So your LCD is x minus 5 times x. That's right, Wills. Yeah. Any place you see a 1 by itself, yes, it needs, or a whole number. A whole number or anything that's not a fraction.
Could I have done the subtraction part first without?
Yes.
Can you do it that way?
It's a little more work, y'all,
What?
doing it that way.
Yeah, I know, but I thought my answer was so easy.
You should still get 2 answers if, even if you do it that way.
Oh my god, I got that.
All right, so x squared minus 5x minus 8x equals 3x minus 15. X squared. I'm gonna do 2 things at once here, y'all. Stay with me. Negative 13 minus 3 plus. That factors nicely for you. Multiplies to positive 15, adds to negative 16 because the leading coefficient is 1. X minus 15, x minus 1, which means my 2 solutions, which happen to be true solutions, if you plug them back in, you will find
See, I did it the other
they are
way.
not
That was
extraneous.
so satisfying.
I only got 1 when I did it.
All right, so if you do it the other way, you would get, on the left side, you would get x minus 5 minus 8 over x minus 5, right? So then you'd have, if you did it where you simplified, guys, I need y'all with me, not against me. All right, so this is what it looks like if you did the left. I thought I hit pause. Clearly I did not. Okay. This is what it looks like if you simplified the left side first.
Yeah.
Okay. So then the first one, this one needs an x, and this one needs an x minus 5. So I'd get x squared minus 13x equals 3x minus 15. So I'm back at the second step here. Yeah. Actually kind of between these two. Because if you move the 3x, you'd get minus. I think it's easier the first way.
I was gonna do that.
You cut out.